Hi, I'm Richard Mobbs, and this is mathematical tutorial number 4 for the University course TU100, and here we're going to be dealing with small numbers, and this tutorial follows on from the previous one which looked at large numbers. All of my resources can be found on the following website. Our fundamental unit of length is the metre, and we can divide this metre up into smaller units of length. The first division is 100, we call this centimetres, and then each centimetre is divided up into 10 millimetres, which means my whole metre is divided up into 10 times 100, 1,000 millimetres. So a centimetre is 1/100th of a metre, and we can represent that in the decimal form 0.01. A millimetre is 1,000th of a metre, and we can represent that in the decimal form 0.001. If we divide by 1,000 again, we get a micrometre, which is 1/1,000th of a metre, which we can represent as 0.000001. You can see what's coming, just like we dealt with the large numbers, we're getting all those zeros again, and they lead to complications in terms of writing things out on paper, and it leads to mistakes. We can often drop a zero and alter our answers and get the wrong calculation. So let's look at our millionth. A millionth is basically 1/1,000,000. Now we saw earlier that we can represent 1 with a lot of zeros after it in terms of 10 to the power of a number, which is represented by counting the number of zeros. So a million is 10 to the power of 6 because there are 6 zeros. But we are dividing, it's 1/10 to the power of 6, which we can represent as 10 to the minus 6. Which is another way of writing the reciprocal of 10 to the plus 6. So 10 to the minus 6 gives us a feeling that we're dealing with a small number as opposed to 10 to the power of 6, which means we're dealing with a very large number. Let's see what we would do. When we looked at large numbers, we saw we moved the decimal place to the left and we added 1 to the power of 10. But now we're dealing with small numbers. So here's a very small number. And we're going to move the decimal point to the right. Because we want to get the first significant figure, in this case it's the number 1, we want to get that to the left next to the decimal point, or after the decimal point. So every time I move the decimal point to the right, I take 1 off my power of 10. So I start off with 10 to the power of 0, and then I move my decimal point 1 place to the right, and I take 1 off 0, which gives me -1. And I repeat this all the way through until I get my decimal point on the other side of the number 1. And in this particular case, I've moved my decimal point 9 times, but I've moved it to the right, and I represent this number as 10 to the minus 9. So as we've moved the decimal point to the right, we subtract 1 from the power of 10. So if I have my micrometre again, 0.000001, we can turn this into 1.0 times 10 to the minus 6 by moving the decimal point 1, 2, 3, 4, 5, 6 places to the right. So we end up with just simply 10 to the minus 6. How small can we get? Well, we've looked at a milli, 1,000th, and we've looked at a micro, a millionth. We can keep dividing by 1,000, just like we did with our other numbers. When we're looking at large numbers, we multiply by 1,000. We can keep dividing by 1,000. My next number is the nano, and then the pico. The pico is 10 to the minus 12, and the femto, which is 10 to the minus 15. So we're dealing with some very, very, very small distances, and we'll meet these when we look at things like the wavelength of light and the frequencies and various things that we deal with when we look at wireless technologies and things like this. We will be looking at very, very, very small numbers when we look at the wavelength of these units. All of my resources can be found on the following website, so I do hope you enjoy them.